So, oops, the music just stopped. Yeah, that's fun. It's so frustrating. And that's a distance. That's times that. Mm-hmm. Mm-hmm. 'Cause I actually kind of like using commas. Four over three. That's 12 over 3. That's 16 over 3. So that's 4 over root 3 times 800,000 plus 2 over root 3, which is 5. Well, whatever. Just some fucking number. Well, I can turn it to 3 though. And that's 4 over 3. And then that's 15 minus 4 root 3 over 3 times 400. Some number. I just hate doing fucking numbers. Two, 9, 2, 7, 6, 0. What's Homeboy saying? Oops, that's not max, that's min. Although it is a max, but it's min. I guess I should be writing min. It's like a this is kind of a cool problem. Okay. Luminosity. The illumination of an object. Strength of the sun. The power divided by, or the energy divided by the distance. So I could just say like the luminosity equal to the energy divided by the distance. And that is, let's just say L, and it's the inverse square law, so it's some constant over r squared. So I have L1 is 3 over r squared. And then I have L2 is 1 over r squared. Now I want to minimize luminosity. And then I have L1, L2, and I have some point here, which is my object. I can call this x, and this is 10 minus x. And I want to reduce them. And x is r. So then L min is just the sum of the two. L1 plus L2, which is then 3 over x squared plus 1 over 10 minus x squared. Well, it's actually just my luminosity function. It's not a minimum. And then I take the derivative, so L prime of this is now just negative 6 over x cubed minus 2 bracket 10 minus x. Although I shouldn't do that. What am I doing that for? It's just going to turn to a positive. So negative 2, and then strips out the negative. Am I tripping? Two. Cubed. Let's just take that. That's 100 minus 20x plus x squared to the power of 1. Is that what I'm supposed to do? I feel like I'm not supposed to do that. And that disappears. I can just do this here. Let's just actually do this. I'm tripping out on that. So it's negative 2 times negative 1 times 10 minus x. Then I have 10 minus x to the 4. And that cancels one of them out. Okay. Just doing some checking. And set this to 0. Which is to say that turns to 3. I can just take the cube root. I don't want to fucking factor it. So then I have 10 minus x equals x times, whoops, 3 to the minus 1/3. It's not really transparent. That just is 10 equals 1 plus that. May have done a numerical error there. Maybe don't skip so many steps. So I have x over 3 to the 1/3 plus x 1. So that's, yeah, I did a numerical error. So that's 3 to the 1/3 plus 1 over 3 to the 1/3. So it's just 1/3 right there, that's all. And x is 10 times 3 to the 1/3, 3 to the 1/3 plus 1, which is just some stupid number. Okay. Is there a nth root? No. Oh. It's 5.9. I guess that's a measure of feet. So then the luminosity, and this will be a min. Luminosity max is when x is 0, which doesn't exist. But that's fine. So that's then just Oh, that's not right. Clear. Yeah, okay, whatever. Just left it as this. That's fine. Seva. Oh, what the hell is this? Find the length of the shortest line segment that is cut off by the first quadrant and passes through the point AB. So here exists A comma B, X, and Y. So I have my line X equals 0 and my line Y equals 0. Point 1 AB is the same as point 1 XY. So I have the distance that's a shorter line. So that is 0. Like that's the problem here. So I know my distance function is just going to be, do I do minus A? Those are arbitrary points. So find D min, but I have 2 variables, so I'm going to eliminate one. I was asking, let's read it one more time. Let A and B be positive numbers. Find the length of the shortest line segment that is cut off by the first quadrant and passes through the point AB. So line segment cut off by the first quadrant. That's going to be rectilinear, right? Like, should be some sort of square. That line segment, like this would just be point 0 comma y, and this is just point x comma 0. So I think that's what I want, and I want to minimize it. Like, is this implicit differentiation? Hey, how's it going? Yeah, pretty much. I want to minimize this line segment. I'm just starting to like get into it. I feel like it's just the derivative of the distance function. But I have two variables, so I'm kind of like mulling that over. Like A and B are constant, X and Y can change, and that's the part that I'm like, ugh. So, like, just implicitly, like, D is going to be a constant. Well, it's going to be a function. It's a function. Oh, could I actually just say this? And the slope is just B minus 0. The slope is just B over A. Well, yeah, I know. Let me just, and it's for sure not Calc 2. I'm only in chapter 4. So I think this is it. Like it really just wants me to substitute y in as a lot, like y is some line. Like so I think I just substitute in these constants like granted x can't equal a, but that's fine. I'm gonna try that. I'm just gonna leave that as mx plus y naught minus b squared. Do I? Yeah, I'll just do this implicitly because I'm lazy. And then that's all 0. And that's going to be negative, so let's keep that in front. So, oh, no, there's no 2's left. My naught minus a minus mb. So x equals, I can substitute m back in if I wanted. And then m y naught. Yeah, the question's it's written kind of strangely. It says let A and B be positive numbers. Find the length of the shortest line segment that is cut off by the first quadrant and passes through the point AB. Unless I'm just like making this way too complicated, which I have a tendency to do. Oh yeah, maybe I am. So like, well, if it goes through, what's M? I don't know if the solution is actually gonna cut out and get to the right answer, but it might. It might not. We'll stop briefly and try something. No, I think this is way too much. It's not one that. Don't think it wants that much algebra. It is a weird, like, yeah, it's a very, like, I think this is the right setup for it. And then I just kind of like define x or y in terms of x. I don't know, I got this like just jargon. Oh no? Okay, what would be the right method? Like, isn't that the, like just a distance function? I hear it. I kind of want to figure this out. I don't like not knowing. I don't know where it is. Yeah. Yeah. Yeah, okay, I hear it. Maybe I've got enough information from what you just said that I think I can. I thought maybe it might have been something like that, so you're right. Y is, yeah, let me say y equals y naught equals m x minus x naught. Yeah, I mean, still not really. The magnitude of a line. Hmm. Yeah, I'm aware of all that. It's the minimization of the length, right? Like if I have a line segment like this this line here is has the magnitude according to its x and y components, right? So if I want to minimize the length, like it's always going to be rectilinear to the x-axis, I would think, or y-axis, whichever one's closest, unless it's perfectly in between, and then it would want to like travel to either axis. So like if I just define y is equal to m x minus a plus b, and then the distance squared is just x squared. I would want to minimize that. But you still have this unknown slope, which is kind of what I had going on here. But it's still implicit differentiation, so it's not. We still have d1 equals 0, which equals 2x. Whatever, I gotta rewrite that. E disappears. Oh my god, I'm like seriously so fucking confused by myself. Like it's just not even, it doesn't even, it's unreasonable. Oh my god. It's actually, it's just wanting me to solve for M. Yeah, I was starting to, well, and then I just substitute that back into the distance formula, which isn't, it's, yeah, it's a disaster. It's like an actual like mess. And I just take this and substitute back into like d squared is now m e minus m squared a squared plus m bracket minus a plus b squared. Which is like the last thing I want to fucking do. Oh, dude. It's like, I don't remember there being so much algebra. Just like every time I get these things, I just keep thinking like I'm obviously doing it wrong. That's all I think when I'm like doing this much algebra. There must be something I'm messing up. But I don't like an M. Like, am I supposed to just state M as like B over A? Like, I just don't think that's accurate. I think it's supposed to be like defined as the difference to a variable x and y. Yeah, it's another Stewart problem. what it's saying is, like, if we go to the graph here, and I'll read the question exactly. So this is kind of what I've written out or drawn out. Let A and B be positive numbers. Find the length of the shortest line segment that is cut off by the first quadrant and passes through the point AB. So you want to minimize this line and have it pass through this point. So if there's a line or something like that. Yeah, like Pone. I don't know how to say your name, but I think you're. I think he's like the solution is. Yeah, dude, that's what I like. That's exactly what I thought. Like, no matter what, the minimum would always be like a rectilinear line to the axis. So it's the minimum of whether it's A or B. But it says the actual minimum, like the solution in the book is this, which is not. So, and now I have this nightmare algebra in front of me, and I'm like, it cannot be this, but keep continuing. I don't want to rewrite that out on the back of the page. Oh, no way. I did not read that question at all correct. Okay, I can start that fresh then. So, oh, dude, you're a gem. Yeah, because I was looking at it the exact same way. Like, let's just call this P1. So now I just want to find this line segment and minimize that. And then P1 is A comma B. Dude. Because if it's this way, it has to be A or B or whatever. This would be A and this would be B. But it has to, but like unless we're in like some curvature of space. But I don't think you do that in Calc 1. Dude. Yeah, dude. Yeah, I think the question was worded horribly. Like, I just thought it had to like, oh man. Okay. Dude, gem for the win. All right, let's do this then. So my line is now. So this is x naught. This is y naught. So negative. But it has to pass through point AB. So my slope is then going to be e minus y naught. I still think I get a jargon of like So what you're saying is that the intercept divided by, or the line, the variable divided by its intercept sums to 1. I gotta think about this here. So that is my slope. I don't like it. It's gonna make a mess again. No. Why not? It'll just be over A. Do I eliminate y naught now though? That's the question. have this horrendous why not though. That's annoying the hell out of me. Hmm. Like I have such annoyance for this why not. Or is this supposed to be gone? It's still like there's a couple every once in a while. It just you get like an obtuse amount of algebra. Like if this isn't there, this problem actually gets a little bit easier. Where did I pick that up from? From here. Let's see if I can just do it without that. I'm just going to do this in factored form. So 1 plus, and that's just m anyway, so 1 plus m squared. Okay. Now I have this, which is why not times m. Jesus, that looks so much nicer. So x is then just why not m over 1 plus m squared. So then my distance squared is why not m plus m squared plus m times why not m 1 plus m squared. My script is messy here. Plus why not squared. Let's do this. No. That's to the 4. Jesus. A lot of m's. How is that any better? This is such a... Okay. I'm not substituting m in. Like, I don't want to leave this problem. It's bothering me. Can I actually just state that the slope is AB or BA? Like, could it not be negative B over A? Maybe that's all it wants me to do. I don't need this Y naught. Yeah, why did I leave that in there? Oh, dude, come on. I should know better. Yeah, it just drops B over A. Okay, how can I resolve this without making a disaster? I still have Y naught though, but I don't want to keep it. Okay, let's go through ditch all this shite. So that's X times M. Okay, that's fine, plus Y naught. Jesus Christ, I don't like this Y naught. Maybe I can determine Y naught in terms of AB. No, no, I can't group that because of the denominator. You jerk. Because I just left this out. I forgot. Let's see if I can solve for why not. No, why not? It's just some, like, y equals m times 0 plus 0.1. It's irrelevant in some way, isn't it? Dude, what the hell is this problem? No, I can. Man. Yeah, it's okay. I don't feel too bad then. Like, it's. Yeah, no, I mean, the solution they have, like, the solution is simple. Like, they had, was it a point? Or, no, it must have been a magnitude. Yeah, it's the solution they have. So this is the magnitude of, let's just call it the line. I don't think so. I don't know. I haven't, I haven't set anything up. So I honestly, I've only just started doing this. So I should find some way to moderate some of the comments. Someone was saying some really stupid stuff yesterday. Like this is, yeah, magnitude. Yeah. Magnitude. Nice. You guys are clearly doing well. As you can see, I do not have that form. Yeah, I feel like there must be some like trick that's just going through easy. Like it just doesn't make sense why it's that complicated. Yeah, like even the next problem, I mean, there must be an easier way. Yeah. Well, the next question isn't much different. It says, what is the shortest possible length of a line segment that is cut off by the first quadrant and is tangent to the curve y equals 3 over x at some point? So I believe it's the same sort of setup, except we're dealing with like a hyperbola. That might not actually be as bad. You just want to find the shortest line segment. So I guess we want to find something like this. Hmm. And these numbers aren't. I should just write that x naught, y naught. Yeah, minimize the tangent. So this is, yeah, it's a tangent. Whatever. So, like, if we go back to this problem, Oh, hey, hey, famished. So if we're back on this problem, what if you had like a normal line and like the normal line has to go through the origin? Would that help? So then like the normal slope, then you I like then the slope of the normal is negative a over b, so the slope of the other line has to be b over a. Oh no. Slope would be positive a over b, so this would be negative b over a. How do you get into physics? Um, I don't know. Are you interested in physics? I think that's the beginning. Like if you like doing physics, or if you know, you're curious about various properties of the physical world. Yeah, then you just have to like take an honest guess of where you are where your mathematical skills are, and just be like, okay, well, go to school, or I'm sure there's loads of YouTube like educational, like you can. I know MIT does a lot of like online courses. Like they'll just have their course classes and lectures on YouTube, so you can watch those. But you need to be able to work the math. And all the math is online too. Like you can get loads of sample sets and problems. I'm sure you can download textbooks now, or even go to the library. Yeah, the open courseware. Yeah, that's what it's called. Dude, that is a wicked that if you're interested, go watch that stuff. Yeah, dude, the open courseware for sure. And in Canada, we have something called the Perimeter Institute. That's pretty cool. They have some pretty cool videos. Like Niels Turok used to be the head of it, and he's a crazy, like he's super talented physicist. Yeah, dude, that's a perfect place to start. It's like you got to start where you're at, man. And then like math is like any skill. Like if you want to learn how to like play a guitar, you know, just start learning how to play like Jimi Hendrix or whatever, some super talented guy. Like, dude, you start playing like some scales and some other things. So yeah, it's just a commitment. Like it's definitely a commitment to the struggle. Yeah, information technology. Yeah, trying to think even what that like I know that's IT, but I don't really know much about what that material is. Like what you actually do with IT. I've avoided computers to the best of my ability at all times. Man, this problem is just so frustrating to me. Okay, yeah, programming. Yeah, Like, I don't know what, like, is that like Python or like, I don't know anything about computer programming at all. Like, I know some of the languages, but I couldn't beyond typing "Hello World," which is the Python intro course line. Nice. Honestly, if you really like physics and like whatever it is that you like, whether it's like astronomy or astrophysics, and or if it's like a quantum theories and ideas like that, uh, I would just keep reading it and just do the math. Like, just start where you're at, just practice every day. Like, I practice every day, even though I'm not really trying to get back into physics. I remember actually uh, one of my professors, I forget his name. He was some Russian guy. He worked on the cosmic radiation, microwave radiation map, and I did a whole essay, presentation on dark matter. Again, I was essentially trying to disprove it because I hated the idea of what dark matter was. Is that like there's something that we can't see that holds together our theory? And I was like, well, it makes more sense that our theory's wrong and dark matter isn't there. And it was actually really enjoyable to like sit there and like here's a guy that's literally like devoted his life to dark matter and just kind of like pick at the idea. But yeah, undoubtedly, yeah, he stopped my idea pretty quick. I think Penn Center's been here a little bit. Yeah, I think this one's way easier. I haven't even started it. I should actually dig in. That other one, it's so hard for me to move past it. Like, especially when the solution's so simple. Like granted, there's going to be algebra that reduces to that, but I can't even see it yet. I think you want to minimize like the normal. Maybe just minimize the normal line. Oh yeah, yeah. Penn Center said something about like there's a discard group that they got. I don't know. I just started, so okay. Let's try this. Oh, I can just do this. Is that what I want to do? I want this in X naught. am I doing? Is this appropriate? No, that's not true. No, I've done something wrong here. So that's 0. That's, I don't know. Well, yeah. I mean, I think I've done the same methodology as you guys. I just stop because I keep getting to the point where I'm like, I don't want to do the algebra actually. Like substitute everything in. And I may be doing it wrong still actually. Well, it's a good place to do your algebra if you're want to chill and do math there, famished. Yeah, dude. That's for sure where I'm at. Like, I don't want to, like, it's horrendous. There's a couple times already in this section, though, that I've had a couple fourth degree polynomials. And I'm like, oh, and that is the way through. Like, they want you to solve it. No, dude, there's like, in this section, I've got a loads of times where I'm like dealing with r to the power of 4 and having to solve it. That's quite a few courses. Okay. Well, let's try this. Nice. Yeah. Yeah, whatever works best for you. It's a good method. I don't think I've done this right. I think I've ignored something. Let's put point 1 is x naught comma 3 over x naught. No, I think I've done it right. Yeah, it's right there and there. So then f of 0 was 0, negative 6x naught, and 0 for x is minus and negative, so that's positive, so then that's x naught equals x minus x naught, so x is 2x naught, so the distance 4x naught squared. Yeah, I have to minimize that. I think x naught, that is the point. Hmm. Yeah, I was looking at that, like, even if I have the common denominator, it's not really, it's just like 2 over x naught times x naught to the 4 plus 9. But I just looked at the solution because I was curious what they had. And they have their solution is that the min, like the distance min, is 2 root 6. So they have a numerical solution for it going through a random point. So x naught isn't sufficient to keep. It's like here's the 2, there's the root. So really it's just telling me that x naught squared plus 9 over x naught squared. That has to equal 6. Hmm. Hmm. Something went blue. That's what it was. Hmm. Yeah. Man, it's so frustrating when it's just not working or not clicking. Come on, one thing. Hmm. Okay. Yeah, I mean, I think if I remember correctly, Walter Lewin, I think it was his name, Walter Lewin. He did like physics, and they were pretty good. They were really good courses on the OpenCourseware. I can never tell if the screen's blurry. I think it looks fine. Why am I struggling? It's so frustrating right now. Okay, I'm gonna dig in. They have a numerical solution, so I need one. This is the line. Goes through some random point. I need to minimize the distance. I haven't minimized the distance. I just found the distance. So what is x for the minimum? That's where I want. Okay, so d squared is 2x squared plus 6 over x squared. So d prime is 2x plus 6 over x. Set that to 0, solve for x. So do not give me a negative. What the hell? Oh, I didn't take the derivative of this properly. That's why. Okay. So drop the 2. Take the derivative of the inside. Turns negative. Negative 6 over x squared. Good. Move it over. Multiply it up. X equals the cube root of 3. Am I tripping? I'm tripping. Or 3. Cube 3. The cube root's not really what I want. Oh yeah, dude, anything you learn is going to be really good. Like it'll help you just sort of be able to focus on different topics. Or like the math if you get really stuck on the math. I mean, 9 times 4. So that's 4 times 9 over that, which is, if I turn that into powers of 3, that's 3 over 2, which is 3 to the power of 4 over 3 to the 1/2. Gee, this is not looking right. What the hell? Hmm, I appreciate that. But I did just take the magnitude of the length. Take that. That's that's what I want, but I have a cube root. That's the distance of them. That's for sure the right distance. It's like it's right there. It's like 2. Oh, does it? Oh, it does. God, dude. Okay. Differentiation of this is just, well, okay. Okay, let's erase all this because it's obviously wrong. Dude, you guys are gems. Okay, so this is 36 over x squared. Yeah, so it should be cubed. So then that's 36 times times 2 though, right? Or is that wrong? Like it should be, and then that's x cubed. So then, okay, let's go through that then. So then move that over, drop the 2. So then I have x to the power of 4 equals 36. And that tells me the fourth root of x is equal to the plus minus of, what's 3 things that multiply to that? Well, I just do 2 times 2, 4, 8, 16 times 2. No, it's 18 times 2. No, I did. No, no. I pull, I drop the 2, yeah. So this is 36. Oh my God, dude. It's so frustrating. Okay, so that's 2, and this is 36, and that's x cubed. So then that's x to the 4 to the power of 18, or to the 218. So the square root of the fourth root of 18. That doesn't make sense. Why do I have the fourth root? God. The factor of 4 comes. But I think 2x is just, it's just the, what x equals. Should be the fourth root of 9. So the square root of, yeah, okay, I see what's going on. So this should be a 4 is essentially what the problem is. That's what it is. I'm squaring the 2. No, that's not right. Yeah, yeah, that is it. It's a 4x here. Because it's 2 squared, 2 and x squared. So then that's to the power of 4. Oh my God, Jesus. Which is 9. Which means x is... I gotta stop trying to do too much in my head and just write it out instead of just make mistakes all the time. Plus minus the root of 3. And that means x is 3. Which is what I wanted the whole time. Is that not correct though? Like if it's 2x to the power of 2, that's the same as 2 to the 2, x to the 2, which is then 4x squared. And then if I wanted to take the derivative, that's 8x. So then if that's like y, then 8x. Is that not correct? Like I feel like I'm doing some error, but I feel like that's actually the correct method. Like, I think that's right, because it does give me the correct solution. So then when I plug this all back in, I end up with the distance is equal to 4 times root 3 squared. Yeah, it definitely, it's like, it's still the same problem where I'm acting like I can do the calculations in my head when I'm clearly not able to. Like I'm dropping and making mistakes and turning complicated problems into things that shouldn't be complicated at all. So then that's 9. So then that's 4 bracket 3 plus 3, 1/2, which is 2 root 6. Oh, yes. I don't know if it's in the screen or not. I can move that maybe, and I can write where I want to write. Seems like it's gone very gray on the screen. I mean, dark back there. Whatever. What's how we doing? What? Oh, I scrolled to that. Yeah, well, I've definitely lost my touch. But that's fine. I'm getting it back. Getting the groove back. Okay, next problem, cost averaging. Okay, that's a lot. Okay. I don't know if it actually wants me to solve for the minimum. Show the average cost is a minimum. Yeah, it just wants me to do that. So C over X. Okay, so then the marginal, so cost is average. If Yeah, I remember one of my friends in university, which would have been around like 2005 or 2006 or something. He was watching those, and he kept telling me, "He was like, you gotta watch these." So oops, 1,000. I really don't want to calculate that. Whatever. So 180. So C of 1,000 is equal to A over 1,000. And marginal cost. You know what I can do? I can take the derivative now. I'm not doing it. It's all just number calculation. I hate doing this stuff. Yeah, I'll be right back. Yes. Right. No, I don't want to do that. No, that's good. Oh, should I skip them? No, just do it. Okay. Okay, here. Let's write this out. Capacity is that. Cost is $10. Average 27,000. The cost was 8, and average profit 33,000. No, that's fine. Okay. Okay, what am I doing? So it said assume a linear demand. So number of tickets, number of tickets sold. Oh, number of tickets. Oh, I cannot write. Okay, is uh, I assume it's 55,000 minus, is it 3,000 for every dollar? The cost, this is just like, yeah. Cost is just 10 minus x. Is that really it? No. I hate doing these numbers. No, it's not that. But that's not really what it is. Okay, we'll do this a little bit more. Number of tickets. It's not this. No. That's a capacity. it's just in somewhere. And that's not the right formula. Oh, come on. I mean, I just want to, I know what to do, I just don't want to do it. And the numbers aren't really adding up. No, they even did it. I think there's a typo in this. I think it's supposed to be 57,000. But I don't really care anymore. You know, I don't even want to do all these thousands. Am I doing this right? I don't think this is right. I don't think that's right. This isn't right. I don't think it's supposed to be more. Well, they use 57 for some reason as well. Doesn't really change it that much. This is what they have anyway. I don't want to do this right now. Oh, nice. I don't think I've never heard of Mary Boas. Boas. Nice. I gotta take a break from the math because I'm just checking out. I'm doing stupid mistakes. What's the mathematical methods on though? Like, is it just like theory? Oh, cool. Yeah, I gotta grind to get back up to that, like understanding it. Oh yeah, it's super smart. It's not too bad. We did, yeah, I did a little bit on tensors, like matrix. That was quite interesting. That was right at the end. I really want to get back into doing like, I guess more of like the E and M and quantum stuff. My math is just not up to it at all right now. I also really like dynamical systems, actually. I love dynamical systems. I might actually grab that for a second. I can do that. I totally could do that for a bit. Let's move all this stuff. Yeah, dude, dynamical systems is such a cool like study. Like I just love doing that. It just seems so cool that everything was like it was all about stability and like finding these like zones or regions. I really enjoyed it. Yeah, that's good. That's pretty good. I'm reading the history of math. Yeah, I'm just kind of burnt out on math right now. I don't know if you can see it. Like actually doing math, and I just kind of want to start reading some stuff. I'm going through all my old textbooks. Might not be the most lively stream right now. I just kind of was working on that last problem. I just had to check out. Yeah, dude, math history is so cool. Hmm. Yeah, I think this is Victor Katz. We didn't really use the textbook much, actually. Like I remember going through this class and thinking like how superfluous the text was. Like he just gave us like you know essays that had been written. We read those. Oh, so tired. What's going on? Yeah, I had to take a I had to take a skill based or not a skill based a written based class to prove I knew how to write an essay. So they made all these like courses that were like for math students. So I did my essays on Fourier. I remember the teacher, I didn't know how to write about him without actually writing about math. It was weird. Yeah, yeah, totally. It sucks when like someone just critiques what your opinion is on something. You're like, ah, dude, I don't care. Like, I kind of feel bad reading now. I'm just kind of like checked out on the math. Maybe that's a good time. Maybe I'll stop the stream. I feel bad just reading. It seems like a rude thing to do. So, okay. So random entry in Pascal's triangle. So that's Pascal's triangle is this, right? And I want to pick what's the probability that it's odd? Probability odd. So the sum of units is 1, 2, 3, 4, 5. So it's a triangle number. So, and I have to think of the number. So, hey, I'll work on that. I'll think on it over the day. But I am gonna actually I think I should end the stream because I'm just starting to read and kind of zone out. Uh, but I'm gonna also be taking off, so I might stream over the next 3 or 4 days, but I might not because I'm going to visit my mom on the island, so I might not just be around. But if I don't see you guys in the next bit, I should see you guys tomorrow. Maybe 24th, 25th, 26th. I probably won't stream. Peace.